Alright, so what we want to look at right here are some rational expressions, operations with rational expressions specifically. We're going to start with just a simple simplifying problem and move on to some multiplication, division, addition, subtraction, and finally we'll do a couple complex fractions. This is a challenging unit because of its requirement that you understand both factoring and fractions, and there are a lot of processes here that seem similar until you really get used to them, which is tough. Now you've noticed the instructions up here: simplify, find an expression which is equivalent if no denominator is 0. These are basically equivalent to any directions that could be given for any of these problems. You're going to simplify, that's what we're doing. If you simplify, you find an expression which is equivalent. The part about no denominator being equal to 0, well, that goes to what we talked about before with restricted values. We know that certain values make a denominator 0, which causes division by 0, which we know we can't do. All right? So that's not something we're going to worry about particularly. What I want you to focus on is really understanding this math so that you can duplicate as much of it as possible. There are also certain ways to test values or compare equivalent statements using your graphing calculator, but what I want to focus on is, again, reviewing how to do this so you'll have at least some understanding of how to do it. Alright, so this first problem right here, 3m squared plus 4m minus 32 over 3m squared plus 45m plus 132. What I am asked to do here is simplify this. And simplifying means that I have to factor. Don't be fooled by the fact that these both start with 3m squared. Those are not factors. I need to factor this before I can worry about simplifying anything here. So what I'm going to do is start by factoring this. Now as I go through this problem, I'm not going to show you how to factor every single polynomial because it's something that we've been working on all year. I'm just trying to get you to review this content and see some problems that you might see on your SOL. So this very first expression, the numerator, 3m squared plus 4m minus 32. Well, when I want to factor, the first thing I always do, is to look for a greatest common factor. Well, the greatest common factor here is 1, because 3 does not go into 4, they share nothing, and it certainly doesn't go into 32 either. So what I need to do is actually factor this whole thing. So the way we talked about factoring this, I would multiply these two and get negative 96m squared. And I can bring down 3m squared, and I can bring down negative 32. Okay? So what I need now are factors of negative 96m squared that add up to 4m. Well, the variable part is easy here because if it has to multiply to m squared and add up to something with an m, that's m and m. But what multiplies to negative 96 and 4 is not immediately obvious. So what I need to do is figure out what does multiply to 96. Now you can do this with a calculator just by doing successive divisions, or some of you have probably seen this trick that either from a friend or I showed you, where if you go to your y equals on a graphing calculator and enter in y1 is 96 divided by x, then in the calculator's table you will actually see a table of factors for 96. So 96, the nice factorizations are 1 and 96, 2 and 48, 3 and 32, 4 and 24. 5 does not go into 96, so I can skip that. 6 goes into 96 16 times, and 8 goes into 96 12. And at that point, I've run out of nice factors. Well, I have to multiply to negative 96, which means I need one positive number and one negative number. And I have to add those up to positive 4. Well, if I think about that, I can figure out that that means I must need to use 8 and 12. Specifically, I need positive 12m minus 8m. Alright, so when I'm doing this, remember, when you're factoring, once you've written down these two numbers, make sure they actually do what they're supposed to do. Plus 12m minus 8m. Their product, when I multiply them, needs to be negative 96m squared. It is. Their sum, when I actually combine them, should be plus 4m. It is. So I know that I've picked the right two factors. This is the common place where people mess up in factoring, is they accidentally write down the wrong two factors. Sometimes they'll notice they made a mistake as they go through. Sometimes that mistake gets hidden by just the way the problem folds out. So be very careful when you're picking these factors. Now after this, I'm going to group these into two pairs of factors, or two pairs of terms, excuse me. The greatest common factor of the first pair is 3m. And if I factor that out, I am left with m plus 4. because 3m times m is 3m squared, and 3m times 4 gets me plus 12m. For the second pair, well, there's a leading negative, so I know I want to take that out. And 8 goes into both 8 and 32, so that'll be my greatest common factor, negative 8. So when I take that out, I will get m, and remember, since I'm taking out a negative, it's going to change both signs. Instead of negative 32, I will now have plus 4, because I'm dividing out that negative 8, excuse me. All right, well, I've done now most of the work for factoring. My factors are m plus 4 and 3m minus 8. And the numerator is thus factored. Now I'm going to go ahead, I need to factor the denominator as well. So I'm going to go ahead and do that right below here, and then I'll do my actual simplifying, my rationals work on this side of the paper. All right, so 3m squared plus 45m plus 132. Now remember, your first step in factoring has to be to look for the greatest common factor. Otherwise, if you don't do that here, you'll end up having to look for factors of 3 times 132, which is 396, that add up to 45. They exist, but again, you have to take out the greatest common factor. If you don't take out the greatest common factor, you're not really doing factoring the way it was intended. So, this leaves us with m squared plus 15m plus 44. All right, m squared plus 15m plus 44. Now, one of the other things we talked about as we moved through the year is the fact that if this polynomial right here has a leading coefficient of 1, which it does, I know there's a 1 right here, I can just factor this without doing the entire process I have up here. Because the first thing I would do is multiply m squared and 44 and get 44m squared, and then look for factors of 44m squared that added up to 15. Well, what we discussed is those numbers will actually just tell me directly what my factors are. 44 is, among other things, 4 times 11. And what do I know? 4 plus 11 is 15, which means I can actually factor this as m plus 4, m plus 11. And you can check, if you multiply this out, m times m is m squared, m times 11 is 11m, 4 times m is 4m, so there's your 15m, and 4 times 11 is 44. So I know that I factored that correctly. All right, so I factored the numerator, I factored the denominator. Let's rewrite this over here. My numerator was m plus 4, 3m minus 8. My denominator was 3 times m plus 4, m plus 11. All right? So here's where the actual rational part, the understanding of fractions, comes into play. I have factors common to my numerator and my denominator. This m plus 4 is a factor of both the numerator and the denominator. Well, m plus 4 divided by m plus 4, is 1 in almost all situations. It's not 1 if m is negative 4, because then this is 0 over 0, and I can't do anything with that. But it's 1 in almost all situations, which means they can be simplified together, or as you might say, canceled out. Okay? So those simplify, and I'm left with simply 3m minus 8 over 3 times m plus 11. Typically, that'll be how you'll see the answer. Most of the time, we prefer to leave our answers in factored form for rationals. So this would be how you would expect to see the answer. But be aware, of course, obviously I could also multiply in that 3. I could distribute and make the denominator 3m plus 33. But I'm going to leave it like this. So again, what am I saying? I'm saying that this expression right here and this expression right here are equivalent for all values of m so long as the denominators are not 0. Okay? So if I looked at this denominator, my denominator had these factors, 3, m plus 4, and m plus 11. Those factors would give me different zeros. If I said 3 equals 0, well, 3 equals 0 doesn't produce a solution. If I said m plus 4 equals 0, well, that would mean that m is negative 4. If I said that m plus 11 was equal to 0, that would mean m is negative 11. These are my restricted values. The SLL tends to not ask about those directly, but they are useful in the sense that if I wanted to figure out this problem, I know that I can test certain values of m to see if these two are in fact equivalent. What can I test? Well, really, anything except negative 4 or negative 11. I could test 0 and 1 generally you want to avoid, but I could test something like 2 or 3 or 5 or anything like that and see that these are equivalent expressions. I'm not going to say any more on that because it's a little bit hard to explain in a video without showing you all that work. And like I said, I want to get you to focus on the math. So at this point, I'm going to move on to my next problem, which is a division of rational expressions. So in order to understand this problem, and again, if you need to pause and copy this down, go ahead and do so. In order to understand this problem, I know that dividing by a fraction means I'm actually multiplying by the reciprocal. So I need to pay attention to this division, and I'm dividing by this particular expression. So the first thing I'm going to do is rewrite this so it's a multiplication problem. Then I will have negative p squared minus 3p plus 40 over 9p squared minus 30p plus 9 times, and again I'm doing the reciprocal here, so 9p minus 3 becomes the numerator, p squared minus 8p plus 15 becomes the denominator. Alright, now that it's down to multiplication, here is where I factor. And I'll write it down up here that I need to do the reciprocal. Okay, reciprocal and factor. And I did the reciprocal only because it was division. Don't think you always have to do a reciprocal. You don't. You did it because it was division. Now, I need to factor all this stuff. Some of these things are easier to factor than others. Again, I'm not going to show you every last bit of work, but I'll give you the general idea. As we go through, I'll do less and less for you. Up here, negative p squared minus 3p plus 40. I'm going to come over here and do my work. The first thing I'm going to do is factor the leading negative and make this p squared plus 3p minus 40. Don't forget to keep that negative, though, because that will significantly influence your answer. Well, this is a leading coefficient of 1. The factors of negative 40 that add up to positive 3 are positive 8 and negative 5. So at that point, I have now factored my first denominator. Numerator, excuse me. You also need to factor this denominator, this numerator, and this denominator. I'll show you the work for 9p squared minus 30p plus 9. Most of it, anyhow. The leading coefficient is 9, but looking at all of these coefficients, I see that there is a greatest common factor of 3. So if I think about factoring this, I'm going to need factors of 9p squared, positive 9p squared, that add to negative 10. That might seem a little bit strange at first, but if you think about it, if it multiplies to positive 9 and adds up to a negative, I want two negative numbers. And to get factors of 9 that add up to 10, that would be simply negative 1 and negative 9. Now once I know that, I can determine, and again I'm not going to show you the rest of that work, I can determine that the factors of this polynomial are 3p minus 1 and p plus 3. Excuse me, p minus 3. P minus 3. Okay? You can do that work on your own. Here I've got 9p minus 3 as this numerator. Well, that has a leading that has a greatest common factor of 3. If I take that out, I get 3p minus 1. And p squared minus 8p plus 15, that has a leading coefficient of 1, so I can factor that easily. The factors of 15 that add to negative 8 are negative 3 and negative 5. Okay. Alright, at this point I've factored everything. Now, if this were one fraction, I would look for factors common to the numerator and denominator and look to simplify them. I could do the same thing over here. Now, in each one of those, I don't have any of that. But since I'm multiplying, and I know that fractions just get multiplied straight across, anything in either numerator can be canceled with anything in either denominator. This is one big numerator and one big denominator now. So, I see right here I have p minus 5. Well, p minus 5 can be simplified with this p minus 5. I also see 3p minus 1. Now don't forget here, you also have these GCF 3's. Those can also be simplified because 3 divided by 3 is always 1. Alright, so what does that leave me with? I've got negative p plus 8 in my numerator, and in my denominator I have p minus 3 times p minus 3, otherwise known as p minus 3 squared. And again, these two expressions are equivalent provided no denominator is equal to 0. So again, I could pick a value to test. If you are trying to test something with a calculator or by plugging in on paper, either way, just be aware, if you plug something in and get 0, you should pick a different value. I wish we had more time to spend on that, but we do not. So now I'm going to move on to a multiplication problem. So this one's a little bit cumbersome. This actually comes from the second released SOL test from 2015. If you want to simplify this, you first recognize that it's multiplication. So what I need to do is I need to factor all of these things. Now this one requires a good deal of factoring. Don't give up. It might take some time, but it's very doable. We know that we can factor. We can all factor very well. So right here, I've got 25 minus 4x squared. So that is, if I rewrite it in descending order, negative 4x squared plus 25, which is then the negative of 4x squared minus 25. Well, I know that 4x squared minus 25 is what's called the difference of squares, because both of these things are squares. 4x squared is 2x squared, and 25 is 5 squared. So 4x squared minus 25 will be 2x minus 5 times 2x plus 5. And at that point, I've now factored that numerator. For the denominator, 6x squared plus 9x minus 15, the leading coefficient, the GCF is 3, leaving me with 2x squared plus 3x minus 5. If you try and factor this, I'll need factors of negative 10 that add up to positive 3. The factors of negative 10 that add up to positive 3 are positive 5 and negative 2. So this would be how I'd split it up. And again, I'll leave the full factorization process to you. I can just tell you that the factors that I would get are 2x plus 5 and x minus 1. Got two more things to factor here. 6x squared minus 2x minus 4 has a greatest common factor of 2, so we'll start with that. And then I need factors of negative 6 that add to negative 1. The factors of negative 6 that add to negative 1 are negative 3, positive 2. So again, when I factor this, what you should end up with is 3x plus 2 and x minus 1. Yep, just double checking that. Then I have 2x squared minus x minus 10. Well, the greatest common factor of this polynomial is 1, so there's nothing interesting going on there. If I multiply these two things, 2x squared and negative 10 would give me negative 20x squared. Negative 20x squared, its factors which add to negative 1 are negative 5 and positive 4. Now again, I leave the factoring to you, but I can tell you that this is 2x minus 5 times x plus 2. Alright, so at that point I've factored every numerator and denominator, and yet I somehow have done very little to address this first expression. Let's rewrite it with all the factorizations in place. My first numerator was negative 2x plus 5, 2x minus 5. The first denominator was 3 times 2x plus 5 times x minus 1. For our second fraction, we had 2 times 3x plus 2 times x minus 1 over 2x minus 5 times x plus 2. Now again, we look for factors common to the numerator and the denominator. The most obvious one right here is 2x plus 5 and 2x plus 5. Be careful here. Notice I did not eliminate that negative. That negative is still very much there. Now I also see this 2x minus 5 and this 2x minus 5, and these x minus 1s. So I can simplify those. So then what am I left with? In the numerator, I have a negative, a 2, and a 3x plus 2. In the denominator, I have a 3 and an x plus 2. This cannot be simplified any further. So I am left with negative 2 times 3x plus 2 over 3 times x plus 2. These expressions are equivalent provided no denominator is 0. All right, let me move on to an addition problem. All right, so addition of anything really requires least common denominators. For rational expressions, it's just staring us in the face because we can see that they are fractions. And this makes things more complicated. Although this is a problem based on an SOL problem that is actually rather simple, so long as you understand what the least common denominator is and how to achieve that least common denominator. Looking at these denominators, I see r plus 6 and r minus 9. Neither of those can be factored any further. They don't have a greatest common factor that's interesting. And there's no power on r, so these cannot be factored. Which also means that these are two distinct factors. I cannot multiply r plus 6 by anything to get r minus 9, or vice versa. So I need to understand that these are completely separate and distinct denominators. So my LCD then, my least common denominator, has to include both of them as factors. R plus 6 and r minus 9. Alright, well, how do I create a least common denominator? What I'm going to first do is copy these down, but I'm going to leave a little bit of space in the middle. To create a least common denominator, I need to multiply in whatever factor is missing. So I am missing r minus 9 from the first fraction. From the second fraction, I have r minus 9, but what I do not have is r plus 6. So I'll go ahead and put that together. Alright, now, as tempting as it might be to go ahead and multiply stuff out, avoid that impulse. What I have created here is two fractions, two rational expressions, with a common denominator. So what I actually want to do at this point is rewrite this so they're over a single denominator. R plus 6, r minus 9, and up on top I have 11 times r minus 9 plus 3 times r plus 6. Now you have to keep this straight. At this point, the only move you have is to simplify the numerator. You need to actually simplify this, which means you need to multiply it out and combine your like terms. So if I multiply this out, I'll do my work over here. 11r minus 99 plus 3r plus 18, which is 14r minus 81. All right? So I have 14r minus 81 over r plus 6, r minus 9. Now at this point, it would be my goal to see if I can factor the numerator and in fact cancel anything, or simplify anything, I should say. But looking at that numerator, 14 and 81 do not have a common factor other than 1. 14 is 2 times 7, neither of those goes into 81. And I see here that r, again, is just r. It's not r squared or cubed or anything else, which means this does not factor. So this will be my final answer. Okay, we have to keep it straight that that is our final answer. Now, in terms of addition and subtraction of rationals, this is actually a pretty easy problem. And as I try and find the sheet of paper I'm looking for, this actually mirrors what we've seen on certain SOLs. Hold on one moment. Okay, so here we see a question taken from our least SOL. I'll zoom in a little bit and then zoom back out when I go back to my work. This is very similar to the problem we just did. Now, I'm not going to work through all of it. If you want to copy it down, you, again, are welcome to. But again, if we understand this problem, we can very quickly eliminate some answers. I know that I have to find the least common denominator. Well, I see x plus 1 and x minus 4, which are different factors. So my least common denominator should include both of those. So A and B seem reasonable. C and D have a denominator of 2x minus 3. We can figure out where that comes from, but we also know that it is wrong. It is not 2x minus 3 in my denominator. So C and D can be eliminated as reasonable answer choices. If you also look at B, 13 over x plus 1 times x minus 4, well, we understand that in order to create a common denominator, I need to actually multiply something in. So what would not happen is to have 12 plus 1, 13. B is an unreasonable answer if you understand how to create a least common denominator. So this is a particularly easy problem, especially based on these answer choices. The only reasonable answer is, in fact, A. Now again, will every problem on the related to this topic be that easy? It's unlikely, but be aware that it could be. There are simple things. Always look to make the multiple choice test work to your advantage. If there are answers that make no sense, don't pick them. All right, let's get back to actually looking at some math. All right. Here is a subtraction problem. This is going to be a little bit more work than our previous problem because my denominators actually require factoring, and I need to factor them in order to figure out my least common denominator. So 2n squared minus n minus 28 and 5n minus 20 need to be factored. 5n minus 20 is 5 times n minus 4. 2n squared minus n minus 28. Again, I will leave it to you to factor. You'll need to find factors of negative 56 that add to negative 1, which are positive 7 and negative 8. So I will get 2n plus 7 and n minus 4. And again, the actual work of doing that I leave to you. When I figure out my least common denominator then, well, I look at my first denominator. I need both of these factors. I look at my second denominator. Well, I already have n minus 4 taken care of. But now I have this 5. So 5 needs to be part of my least common denominator. So what I'm going to do, again, is rewrite this. Leave myself a little bit of room to multiply in a missing factor. All right. Now something else that I'm going to do here. I know that that numerator is going to have to get multiplied. So I'm going to put it in parentheses to make sure I don't screw up any distribution. I'm going to put both of them in parentheses. The first expression needs 5, so I multiply by 5 over 5. The second expression needs 2n plus 7, so I will multiply by 2n plus 7. Again, note the use of the parentheses. Okay, so again, at this point, we have our common denominator. So let's rewrite this. 5 times 2n plus 7, n minus 4. And in the numerator, I'll rewrite this as 5 times n squared minus 1, because typically we would put that 5 on the left, minus 2n minus 3 times 2n plus 7. Now what I have to do is actually multiply this out and try and simplify. I'm going to do that work off to the side so I don't have to rewrite this expression 15 times. So that will be 5n squared minus 5 minus, if I multiply 2n minus 3 by 2n plus 7, I will get 4n squared plus 8n minus 21. And you can multiply that by FOIL or box or whatever process you're comfortable with, but know that that is actually the result. I distribute the negative here, 5n squared minus 5 minus 4n squared minus 8n plus 21, which is n squared minus 8n plus 16. Okay, so that's my numerator when I simplify it. All right, now frequently this is where we would be done with this problem. I would just move on and go on to the next problem. However, notice the numerator at this point is a quadratic, which means I actually need to factor that and see if I can simplify this any further. Well, the leading coefficient's 1. You might recognize this pattern. Either way, this is a 16, this is a negative 8, which means that is n minus 4 times n minus 4, or n minus 4 squared. Okay, well then, I can see I have a common factor to my numerator and denominator. Both of them have an n minus 4. On top, I have an n minus 4 squared. In the denominator, I have an n minus 4. Well, if I simplify by removing just one factor of n minus 4, down here I'll lose the only n minus 4. In the numerator, though, n minus 4 squared, which means n minus 4 times n minus 4, there I should only lose one of those n minus 4s. So another way we could represent this is crossing out, instead of n minus 4 squared, I can just eliminate that exponent and say my numerator is now only n minus 4. And thus I have two equivalent expressions, the original and this. Now again, when are those equivalent? Provided that no denominator is 0. So provided that n is not 4, provided that n is not negative 7/2, and 5 equals 0 would not give me an additional solution. Okay? All right. Let's move on. Let's go ahead and look at some complex fractions. Now, there are two types of complex fractions that you could potentially see. This one is taken from an actual SOL, and what we see here is this complex fraction is actually one fraction over another. Now, the general process for a complex fraction is to find the LCD and multiply each term within by that LCD. That's the general process for simplifying a complex fraction that we talked about. And that's all well and good. It works very well. However, here I can do something different. This is a fraction over a fraction. You can see right here, this is one long fraction bar separating two other fractions. So what I can do is think of this as division of fractions. Think of as division. And you can see how bad my handwriting is getting, but don't worry, I'm about to switch back to my regular pen. All right, so my numerator is 11 minus w over 30w squared. That's my numerator fraction. And that's being divided by the denominator fraction, w minus 11 over 5w to the 6th. Okay, well, what did we talk about? Since this is being divided, I need to use its reciprocal. So I will have 11 minus w over 30w squared times w minus 11. Darn it, I meant to reciprocate that. Times 5w to the 6th over w minus 11. My fault. All right, so now, this one's a little bit simpler even than a lot of the problems we've been looking at because the factoring here is very minimal. W minus 11 is already factored. I can't do anything with that. 30w squared, well, that's 30 times w squared. 5w to the 6 is 5 times w to the 6. There's no real factoring, per se, the way we typically think of it, to go on with those. The only one I have to do a little bit of work with is 11 minus w. Now, we've seen this a few times. This is something that comes up a lot on the SOL, where I see an expression with subtraction and the same expression turned around. Well, let's think about what this is actually doing. 11 minus w, I'm going to move this a little bit this direction. 11 minus w is negative w plus 11, which means it's the negative, if I take out the leading negative, of w minus 11. Okay, let's think about that. I now have the negative of w minus 11 over 30w squared times 5w to the 6th over w minus 11. And again, I want to look for common factors, things that can be simplified. Well, clearly w minus 11 and w minus 11. But note, that negative is still there. Now what else do I see? I see 5w to the 6th and 30w squared. Well, I can simplify 5 and 30 because 5 goes into 30. Leave a 6 down there. Now this is one we haven't seen recently, but we remember dealing with exponents before. If I have w to the 6th over w squared, well, what does that mean? That means I've got 6 w's in my numerator divided by 2 w's in my denominator. Well, think back to what we were doing. I can simplify and simplify and simplify. There are 4 more factors of w in the numerator than in the denominator, which means I would be left with w to the 4th on top. Now you might recall this from Algebra 1, subtracting the exponents and saying that this is w to the 6 minus 2. I'm just again explaining why that works. So what I have left now, I have that negative still. As we discussed, w to the 6th over w to the 2nd is w to the 4th. And 6 is my denominator. And I have a very nice and neat result. Now, of course, we could have made this more complicated. I could have had more interesting polynomials rather than just 30w squared and 5w to the 6th and w minus 11. I could have had polynomials that required us to actually factor quadratics. But the process is the same if I have a fraction over a fraction. Let's do one more example here. I know this is taking forever, but again, it's worth reviewing. Let's do one more example of a complex fraction that is not simple. Right here. This is very different than the previous complex fraction I just saw. How come? Well, look at it. In the numerator, I have 2 minus a fraction. In the denominator, I have 2 distinct fractions. So what I want to do here is determine what is the least common denominator of all of this stuff. Well, I see my different denominators here. The denominators I have are x squared, x, and 2x. So the least common denominator then, well, clearly they all have an x. But since this one has an x squared, I need at least x squared. And since this one has a 2, I will additionally need a 2. All right. So now what? Well, here's where the full process of simplifying a complex fraction comes into play. I've got these 4 terms inside my fraction. I'm going to multiply each one by that least common denominator. All right. And I'm going to write this in 2 colors just for emphasis. I'll leave a little bit of space for myself. I'm multiplying each of these by the least common denominator. Okay? Why? Well, this is something that comes up again when we solve rational equations. The idea of multiplying by the least common denominator is, now you can think of this as over 1 if it helps you, but the idea is I'm doing this so that I can get rid of whatever denominators there already are inside. With this first term, there's no denominator to cancel, so I will just actually multiply those 2 together. Here, x squared and x squared can be simplified. Right here, I've got 2x squared and x. Well, I can lose this x with one of these 2 x's. Instead of x squared, I'll just have x. And over here, I can lose the 2. And instead of x squared, again, I will have just x. So what is all that? What did I just change this into? I now have 2x squared times 2 minus 2 times 5x plus 18 over 2x times x minus 3 plus, this is x times 10, or 10x. Now that looks pretty ugly. You need to actually multiply stuff out and figure out what this is. Up on top, what will that be? Well, this is 4x squared minus 10x minus 36. In the denominator, I have 2x squared minus 6x plus 10x. When I combine those, I will get this fraction. 4x squared minus 10x minus 36 for the numerator. And down here, this will be 2x squared plus 4x. Well, this doesn't stop being any more complicated at this point. I need to factor this. So let's look at factoring these things. In the numerator, there's a GCF of 2, which leaves us with 2x squared minus 5x minus 18. And when I go ahead and try and factor that, I will need factors of negative 36 that add to negative 5, which are negative 9x and plus 4x. So that will factor as 2 times 2x minus 9x plus 2. In the denominator, all I need to do there is take out a greatest common factor of 2x. So how does this simplify? This is 2 times 2x minus 9 over x plus 2. And in the denominator, I have a greatest common factor of 2x, which leaves me with x plus 2. And I'm still not done because there's some simplification left to do, which is why we really wanted to do the factoring. Well, you see I've got x plus 2 and I've got x plus 2. Those simplify to 1. What's more, I have this 2 and this 2. Again, 2x means 2 times x. I can do that very easily. 2x minus 9 we know is a separate factor. I can't do anything with that. But 2x, I can just pull the 2 off and simplify it. So what am I left with? This is simply 2x minus 9 over x. A lot of work for coming from something that looks so complicated to something that looks actually quite simple. But those two are equivalent, again, provided no denominator is 0. So if you wanted to check this on a test, if you wanted to pick values to test, pick something random. Pick 7, pick 3. Well, actually, don't pick 3 because it makes that 0. But again, I've shown you the math. Actual tricks beyond that, well, those are up to you.